Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. Use cases of multi-orbit satellite constellations in LEO-MEO-GEO orbital regimes. In the 1960s, the first satellite constellations were deployed to establish basic communication links. Examples of early constellations are Telstar, launched in 1962, and Molniya, launched in 1965. Telstar operated in a non-geosynchronous orbit, providing intermittent transatlantic signal availability for just 30 minutes in each 2.5-hour orbit. Molniya constellation, launched by the Soviet Union, provided continuous coverage over high latitudes, which were not served by geostationary Earth satellite. The launch of Syncom 3 satellite in 1963 achieved the first geostationary orbit, allowing for continuous coverage over a fixed region and paving the way for future generations of large, long lifespan geostationary satellites for television, military, and telecommunications. After the early period, multi-orbit satellite constellations concept was proposed. The constellations combined the strengths of different orbital regimes, LEO, MEO, and GEO, in order to provide a single integrated and highly resilient connectivity solution. Various use cases of multi-orbit constellations span a wide array of demanding sectors where seamless, high-performance, and reliable communication or observation is critical. Examples are industry-specific operational support, Earth observation and monitoring, and a host of others. The focus points are as follows: categorization of satellite constellation and use cases of multi-orbit satellite constellation in LEO, GEO, and MEO orbital regime. Categorization of satellite constellation. Satellite constellations are primarily categorized by their orbital altitude and their intended application or mission type. By orbital altitude, the distance from the Earth's surface largely determines a constellation's characteristics, such as coverage, latency, and operational lifespan. Low Earth orbit constellations operate at altitude between 160 km and 2,000 km. In orbit, target-based autonomy for enhanced stability of small satellite constellation is shown in this picture. Categorization by application of function. The mission of the constellation dictates its technical requirements and choice of orbit. Communications constellations provide global voice, data, and broadband Internet access. Navigation constellations provide precise positioning, navigation, and timing. Isotropic systems connection with multi-orbit feed is shown in this picture. Use cases of multi-orbit satellite constellations in LEO-MEO is shown as follows: in-flight connectivity, military communication, enterprise and government services, telecommunication and global internet access, mobility, industrial applications, and Earth observation and navigation. In-flight connectivity. Multi-orbit satellite constellations enhance in-flight connectivity by combining strength of LEO and GEO orbit satellites to provide reliable high-speed service. Use cases include superior passenger experience with fast streaming and video conferencing, improved business productivity, personalized services, and enhanced airline operations, such as real-time weather data for fuel efficiency. Eutelsat high-speed and low-latency LEO constellation is shown in this picture. In-flight connectivity. Multi-orbit satellite constellations provides high-speed internet for streaming, gaming, video calls, and other data-intensive applications. For business productivity, it allows business travelers to work as if they were in an office with access to cloud services. Improved operations, it allows for more detailed frequent weather information. ESA's multi-orbit concept of next-generation communication is shown in this picture. Military communication is another use case. Network redundancy. Military branches use multi-orbit solutions for mission-critical communications, and this enables them to switch seamlessly between networks. Mobile communicate, they support on-the-move communication for vehicles, aircraft, and automobile platforms. And military communications enables resilient and mobile operations by ensuring connectivity in diverse and dynamic environment. Military satellite communication and surveillance is shown in this picture. Countering threats, large-scale combat operation, and seamless integration are other use cases. Illustration of military satellite communication is shown in this picture. Enterprise and government services use cases are remote operations and precision agriculture. OneWeb plans for a mega constellation of at least 648 satellites is illustrated in this picture. Other use cases for enterprise and government services are smart mining and logistics, offshore operations, and utilities infrastructure monitoring. Illustration of LEO satellites for Internet services is shown in this picture. Telecommunication and global Internet access uses are rural and underdeveloped areas, backup communication systems. Illustration of satellites in LEO-MEO-GEO is shown in this picture. Another uses is in mobile backhaul. MEO constellations are used to provide cellular backup for mobile network. Smart devices and Internet of Things. It enables reliable connection for smart farming. Ultimate multi-orbit geo-LEO satellite network is shown in this picture. Mobility, aviation and maritime. Commercial aviation airlines use multi-orbit connectivity to provide reliable in-flight Wi-Fi for passengers and crew. Cruise liners and commercial shipping vessels also use combined capacity of MEO and LEO satellites. Ground transportation, multi-orbit antennas are embedded into military vehicles and smart farming equipment. Telstar light-speed constellation is shown in this picture. Industrial applications include mining and energy production and agriculture. Orbital design optimization for large-scale site constellation is shown in this picture. Earth observation and navigation. MEO satellites are foundational for global navigation satellite systems such as GPS, Galilean, and GLONASS. LEO satellites also play a crucial role in detailed Earth observation. Multi-orbit sensor systems provide diversified fields and longer tracking times. In-orbit target-based autonomy for enhanced stability of small satellite constellation is shown in this picture. For more information, contact Astronautics for exploits. You've been watching and listening to use cases of multi-orbit satellite constellations in LEO-MEO-GEO orbital regimes by Dr. Ayanshola Ogundele, with the focus point categorization of satellite constellation and use cases of multi-orbit satellite constellations in LEO-MEO-GEO orbital regimes. Thank you.